Hi guys, this is the third and final video on the three-part mini-series of the composite functions. So we are given two functions, namely f and g, and then we are asked to find f of g of 9. So we want to find the composite function and evaluate it at 9. We have different ways to go about it. I'm going to try to show you the less intensive way. So let's do this. So whenever I have the composite function written in this form, it's a little bit difficult for me to have a starting point. So I will always write it without the notation for it, without the small circle. So we have this first function, f of, open parenthesis, of whatever we see thereafter, of g of 9. Okay, so in this case, my first goal is to find g of 9. Sorry, the g and 9 kind of look the same. So, but it's okay. You have better penmanship than I do. So let me go ahead and do a semicolon, and I want to find g of 9. So I want to know what is the value of this function when the input is 9. So you guys are really good about substitution, but I'm not. I will always write down the original function before I decide to plug in anything. So then with confidence, it's like, oh yeah, g of 9, we got this. To find g of 9, we're going to substitute a 9 for the input of x. Okay, so that will give us 9 minus 5 or 4. If this was the only thing I was going to submit for credit, I will box 4 and move on. But because this is part of my solution, I want to ask myself, what equals 4? I'm like, all right, g of 9 equals 4. So remember, always use your notes when you have a quiz or midterm. It would be nice if they're all take home. Cool. So g of 9, according to our hard work, gives us 4. So the moral of this story is that f of g of 9, what that translates to is find f of 4. So you guys are awesome. I know you could evaluate this quickly, but I cannot. So I'm always going to write down the original function first. So we have f of x, yf, because that's what it says. So f of x equals x squared plus 4. Remind me to give myself more space next time. Then with confidence, we are going to evaluate f of 4. So in this case, we are going to substitute a 4 for the input of x. So in this case, we have x, which we're swapping out for 4. What is going on to the x? It is being squared, and then we add 4 to it. The square of 4 is 16. And the sum of 16 and 4 is 20. So after all that hard work, we are going to tell the reader that f of g of 9 simplifies to 20. Fantastic. So this in this short video, we have two sets of exercises. Let's go ahead and wrap it up with our second, which I lied to you. It is the second set of exercises, but it involves 3 problems. So in this case, we are given functions, but we are presented the function in the table format. So the first table, we have x, f of x. So remember, this is like a xy table, but we're using function notation. And this is like another xy table, but we're using function notation. So if we have to use function f, we're going to use the first table. And if we have to use function g, we're going to go ahead and use the second table. And it would be nice if I actually read the directions. So it says, consider the table below for the functions f and g. Evaluate each expression if possible. Oh, I hate it when they say if possible, because that means that maybe something won't be possible, and that's why I get nervous. So problem A, we want to find g of f of 1. This is again hard for me to digest, so I will always rewrite it. So we're going to take this first function. We have g of whatever we have left with, g of f of 1. So now the question is, what is f of 1? So let's go ahead and look at our first table. So f of 1, when the input is 1, what is the output? So when the input is 1, the output is 2. So f of 1 simplifies to 2. But now the question is, what is g of 2? So we have to look at the table for function g. And when the input is 2, what is the output? So when the input is 2, the output is 2. The output is 4, sorry. So that will give us g of 2 equals 4. So the moral of this story, g of f of 1 simplifies to 4, or evaluates to 4. My mistake. Same difference. No one's going to know. All right. Problem B, we want to find f of g of 4. Let's go ahead and rewrite it. We have this first function of whatever we're left with. Okay, so g of 4, when the input is 4 for function g, what is the output? And I'm having a moment because We have a 4 on the first table, but this is the information for function f. Looks like function g is not defined at 4. So if g of 4 is not defined, then there's no way I can find f of whatever I'm left with. So in this case, the composite function is not defined. Or you can just write undefined. It doesn't really know. Just write something to let me know that it's not happening. Or I guess not possible. Okay, for the grand finale, we have find f of 3. It looks a little bit weird, but let's do this. So we have this first function, f of whatever we're left with. So we are going to find f of 3, and whatever that is, we're going to find f of whatever we're left with. So f of 3, when the input is 3, what is the output? So when the input is 3, where am I? The output is 6. So the moral of this story is that f of 3, what that means is we want to find f of 6. So when the input is 6, what is the output? So if the input is 6, then the output is 7. So again, for the grand finale, what we want to tell the reader is that f of 3, that evaluates to f. You guys nailed it. Thanks, guys.